Alright, so now we're going to be looking at the slip ring induction motor. And it's a little bit different to the squirrel cage induction motor which we previously looked at. So if you recall, the squirrel cage induction motor had this cage that it used for the rotor instead of copper windings. So it had these solid conductors, these what they call rotor bars for the conductors of the rotor. And the slip ring motor, so if you look over here, so there's the stator that you're familiar with already, and that's got copper windings for the stator windings, and that's the squirrel cage induction motor. That's the rotor for the squirrel cage induction motor with the solid conductors, or the squirrel cage. And over here is the slip ring induction motor. Now the slip ring induction motor has copper windings which make up the conductors of the rotor, and these copper conductors are connected to slip rings on the shaft. So you can see over here the three slip rings for the three windings on the rotor. Now the reason for the difference is because a squirrel cage induction motor has a relatively low starting torque. So the turning force, or the turning force when the motor is starting up is low. So in applications like in industry, you'll find a squirrel cage induction motor used on an electric, on a pump, where it's pumping water. You'll find it on fans. It's where it's blowing air, for like example on a steam generator. Now, if you think of air, for example, when the motor starts up, there's not much resistance because of the air. So therefore, it doesn't require a large starting torque to start pushing the air. But if you think of an example like a elevator, everyone gets in the elevator and it's a lot of weight in there, hundreds of kilograms, and even the weight of the cage that holds the people in it, it weighs a lot. And as soon as you push the button for the elevator to go up, it immediately starts raising. It starts lifting the load. Now that is an application where a slip ring induction motor would be used, because it requires immediately at startup, it requires a high amount of turning force to be able to lift that load. Now what they've done is, so here's your copper wound stator like always, and over here is the rotor. Now the rotor is connected in star formation, and the windings are copper windings like I said before, instead of the rotor cage. And these three windings are connected through three slip rings that are connected on the shaft, right? And the reason for that is because we want to connect something externally, so something that's outside of the motor. We want to connect something to this circuit of the rotor. And what we actually do is, in series with each of these three windings, we're going to connect three resistors, all right? And these three resistors are going to help increase the torque at startup. So you can see this first winding here, if we just follow it here through the slip ring, and then it connects to this resistor here. Now these resistors, you don't want them in the circuit when the motor is up and running at full speed. You only want them there during startup. So we need a way to be able to connect them to these three windings when the motor is starting up. And when the motor is up to speed, we want to remove these three resistors. So what we do is we use two contactors. So there's the coils of the contactors. And when the motor is at startup, we close the contactor here at the back behind the resistors, and then these three resistors are in the circuit of the rotor. All right, and once the motor is up and running, this will open up, and then we'll short circuit over here in the front. So these three resistors will be shorted out of the rotor circuit, and because at that time we don't need them anymore. So when we doing these calculations, we're first going to start calculating the impedance for the rotor with the resistors engaged, and then once the motor is up and running, we're going to calculate the impedance when the resistors are removed from the circuit. All right, so that's what we're going to be doing in the next problem. So what we need to remember is for this is that the slip ring induction motor gives high torque during startup, and we have these 3 resistors that are connected to the 3 rotor windings at startup. Okay, so remember at startup, the slip, now this is important to note, the slip is 1 at startup, okay, because the rotor is standing still. So the stator's magnetic field, the rotating magnetic field of the stator, is cutting the rotor because the rotor is standing still at this time. So relative to the the rotating magnetic field, the rotor is standing still. So we say that the slip is 1. So whenever the questions say that the slip is 1, you need to remember that the slip then, or the rotor is then standing still. Alright, so in the next video we're going to start looking at how we use these resistors in the calculation.